Hello grade 12s and welcome to this video on structural isomers. In this video we're going to take a look at the three different types of structural isomers. We will define each of these and we will also look at examples of these three different types of structural isomers. We say that structural isomers are organic molecules with the same molecular formula but different structural formulae. So what this basically means is that when we compare structural isomers or two compounds that are structural isomers, we will find that they contain the same types of atoms and the same number of each type of atom. But the way in which they are arranged is different because their structures and their structural formulae are different. We say that structural isomers have the same molecular formula. They have different structural formulae and therefore different arrangements of atoms. Their IUPAC names are different. They have different physical properties. They can sometimes belong to the same functional group, but other times they belong to different functional groups. Here we speak about functional isomers, and they may or may not have the same chemical properties. These are what structural isomers are, and we get three different types of structural isomers. Firstly, we have what we call chain isomers. Chain isomers are compounds that have the same molecular formula but different types of chains. So what you're going to see when we compare chain isomers is that the stem name, the words like meth, eth, prop, but, pent, hex, hept, oct, these names that describe the longest chain are going to be different. We then also have structural isomers that are specifically called positional isomers. These are compounds with the same molecular formula, but different positions of the side chains, substituents, or functional groups on the main chain. So when it comes to positional isomers, we can say that in the names of these positional isomers, the stem or root name, meth, eth, prop, but, that describes the longest chain of carbons in the molecule will be exactly the same because the length of the chains is the same. But the numbers on which the substituents, the side chains or branches, the halogen atoms, or the functional groups will fall will be different. So you're going to see that the numbers within the name are different because the positions of the substituents or functional groups is going to change. Lastly, we have the functional isomers, and we can say that functional isomers are compounds with the same molecular formula but different functional groups. Functional isomers contain exactly the same types of atoms and the same number of each, but they belong to different homologous series. We're going to now look at a few examples of different chain isomers. Remember, chain isomers have the same molecular formula, but their chains or the length of the longest chain is going to differ. Displayed to your screen, we have the molecular formula of two compounds. We have the structural formulae, the condensed structural formulae, the names, and also 3D representations of these molecules. Specifically, these 3D representations are called ball and stick models. I suggest that whenever you are given the structural formula of a compound or two compounds and asked what type of structural isomers you're dealing with, start off by writing out the IUPAC name of the compounds. So here the names of the compound that we're dealing with is butane and 2-methylpropane. As you can clearly see, butane contains 4 carbons in its longest chain, but 2-methylpropane contains 3. They both have exactly the same molecular formula, so they both contain 4 carbon atoms and 10 hydrogen atoms. But if we take a look specifically at the names of the compounds, we can see that the stem name changes from but to prop, indicating that specifically we have chain isomers because the length of the longest chain has changed. Here we have another few examples of chain isomers. We have pentane, 2-methylbutane, and dimethylpropane. If you look at the chains themselves, so if you look at the condensed structural formulae, you will see that the length of the chain becomes shorter and shorter as we go from pentane to 2-methylbutane to dimethylpropane. But the giveaway is in the name. Here we have pent for 5, bute for 4, and prop for 3, and therefore these are examples of chain isomers. The last example of chain isomers that we're going to look at compares two alcohols. Specifically, we have pentan 2-ol and 2-methylbutan 2-ol. Notice here that the position of the functional group stays exactly the same. This is because these are not positional isomers, these are chain isomers. If you look at the length of the chains in the condensed structural formulae, you will see that it goes from being very long to being a bit shorter. But the giveaway, as I've always mentioned, is when you name the compounds. If we look at the stem names, here we're dealing with pent, and over here we have butan. Pent refers to 5 carbons, and bute refers to 4. So these are chain isomers because the length of the longest chain is not the same, even though their molecular formulae are exactly the same. Both of these molecules can be described by the molecular formula C5H12O, or if you would like to, you can write it as C5H11OH. Their molecular formulae are the same, but their structures and the lengths of their chains are different. We will now look at a few examples of positional isomers. Here we're dealing with propan 1-ol and propan 2-ol. These formulae or these molecules are described by the same molecular formula, C3H8OH, or if you would like to, you can say C3H9O. These compounds are both alcohols, so their functional group has not changed. If we look at the lengths of the longest chain, they both have the stem name prop. So it is very clear over here that since the length of the longest chain is exactly the same, that these are not chain isomers. But if you look at the numbers, here we have a 1 and here we have a 2, indicating that the position of the functional group, which in this case is called a hydroxyl, has changed. And since the position has changed, these two are examples of positional isomers, or we can say that the one is a positional isomer of the other. Another example of positional isomers include but1-ene and but2-ene. These are examples of alkenes, and remember alkenes have the functional group which is a double bond between two pairs or a pair of carbon atoms. When we look at the lengths of the chains, we see that they are exactly the same, and we know this most especially because of the names of the compounds. Both have the stem name bute, which refers to 4 carbons in the longest chain. But if we look at but1-ene, we see that the functional group, the double bond, falls onto carbon number 1. And in but2-ene, the functional group falls onto carbon number 2. So we see very clearly here that the position of the functional group has changed, and this is why but1-ene and but2-ene are called positional isomers. Let's now look at the last type of isomer called a functional isomer. Functional isomers have the same molecular formula but belong to different homologous series because they have different functional groups. We find that generally esters tend to form functional isomers of carboxylic acids. And this is because both of them have the general formula CnH2nO2. We tend to easily confuse esters and carboxylic acids, but just remember that the functional group of carboxylic acids always falls on carbon number 1, which can be either on the right-hand side or left-hand side of the carbon. But in esters, the functional group is somewhere in the middle. We also have that aldehydes and ketones tend to form functional isomers of each other. And this is because their general formulae are also the same. They are CnH2nO. And we also tend to confuse these two types of compounds. Just remember that when it comes to the aldehydes, their functional group is on carbon 1, while that of the ketones is somewhere in between in the middle of the compound. Let's look at a few examples, starting off with a carboxylic acid, butanoic acid, and an ester ethyl ethanoate. As you can see, both of these compounds have the same molecular formula, C4H8O2. But when we name the compound, we can clearly see that the suffix, the ending of the names are different because they belong to different homologous series. The one is a carboxylic acid because the functional group, the carboxyl group, falls on the first carbon. The other is an ester because its functional group is somewhere in the middle of the compound. We can also look at an example of functional isomers where we have an aldehyde and a ketone. Specifically, we are looking at pentanal and pentan-2-one. Both of these compounds have the same molecular formula, C5H10O. So the number of atoms in the molecules and the type of atoms is exactly the same. But since pentanal is an aldehyde, its functional group falls onto the first carbon in its chain, while when we look at pentan-2-one, its functional group, although it looks similar, is between two other carbon atoms. It's somewhere in the middle of the chain, and therefore this is a ketone. As always, naming the compounds helps us determine if they are functional isomers or what type of structural isomer we're dealing with. And since the one name ends with L and the other with -one, we know that here we are dealing with functional isomers. This brings us to the end of this video on structural isomers. Please remember that there are 3 different types of isomers that fall under the name structural isomers. They are chain isomers, positional isomers, and functional isomers.